Hello students, welcome back. Happy whatever day it is when you're watching this. Thanks for being here. Today's Flipgrid is at that link. Go answer it. It's good fun. YouTube lesson, you've already found it if you're watching this. And now please try this problem in your notes. Find the measure of the arc JM. Pause the video, try it yourself, and then unpause it to do it with me. Okay, so we are using this diagram right here to find the measure of JM. JM. Remember that arc is the same as this angle measure right here. How many degrees are there in a circle? That's right, 360 degrees. So if I add 53, 85, and 68 together, I will get 206, and then all we have to do is do 360 minus 206, which is 100 and, whoa, that's a 4. 154 degrees. That's what the measure of not angle JM, the measure of the arc JM is. Wonderful. Alrighty. Now, let's move on to what we have for today. So today we are talking about section 10.4. We are talking about inscribed angles and polygons. The question we are looking at is how are inscribed angles related to their intercepted arcs? We'll learn what that means. Next slide. And how are the angles of an inscribed quadrilateral related to each other? So, our learning target is that you know what inscribed angles and polygons are, and our success criteria is that you can use theorems about inscribed angles and polygons to solve problems. So let's jump right into it and see what is an intercepted arc, an inscribed angle. What do these things mean? Well, yes, please write these down. Please pause the video and write these down. The pictures too. An inscribed angle is an angle whose vertex, and remember the vertex is the corner, so this is the vertex. The vertex is on the outside of the circle, and the sides are chords of the circle. Basically, looks like this. That's an inscribed angle. The red thing right here is an inscribed angle. So please put that in your notes and draw the picture in your notes. The intercepted arc, what we mean when we say intercepted arc, is the arc that lies between the segments of the angle. So that blue piece right here, that is the intercepted arc. So we can see that this is an angle and this is an arc. So inscribed angle, intercepted arc. Okay, those definitions should be in your notes. The pictures should be in your notes. And now we're going to move on to seeing what this looks like together, what these vocab words look like together. You don't need to write this down because it's basically what we just wrote down. We're just going to talk about it a little more in depth. So, an inscribed angle and the intercepted arc go together. So you can see them both here in the same picture together. Angle B intercepts this arc AC. We also say that an arc subtends the angle. Fancy way of saying that the arc and the angle go together. The angle intercepts the arc and the arc subtends the angle. And they work together just like you see it in this picture here. Okay, now, this is also very important. The measure of an inscribed angle. So you know how to find measures of arcs. That's what we did last time. That's what we did last lesson. So we know all about finding arc measures. But what about finding these inscribed angles? How would we do that? Well, we have a theorem here that says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Cool. So if we know the arc, we can just take half of the arc, and that gives us our angle. Yep. That's it. That's it. Okay. Just in case you're confused. Oh yes, did I say to write that down? I know it says it right here in the red. But write it down. Make sure you write it down. Picture 2, please. Let's see an example of this in action. Find the indicated angle measure. We want to find... Here, let's get a different color in here. We want to find the measure of angle T. Angle T is right here. Well, remember that this theorem right up here says that the inscribed angle is half the measure of the arc. So the measure of angle T is half the measure of the arc that goes with the angle. Here's the angle, here's the arc, so it is half of 48 degrees. Yep. Half of 48, you probably don't even need a calculator for that. Half of 48 is 24 degrees. So the measure of angle T is 24 degrees. There you go. Now we also want to find, let's switch colors again, we want to find the measure of the arc, TQ. TQ, so now we're looking at this arc. That goes with this inscribed angle. Now remember that the inscribed angle, this, is half of the arc. So, half of the measure of TQ has to be equal to 50 degrees. So half of what is equal to 50? Half of what? Oh! $100. Half of 100 is 50. So the measure of TQ has to be 100. The other way, instead of just thinking about it, what half of what is 50? Instead of doing that, you can just multiply both sides by 2. That has your halves cancel out. And then you get 50 times 2 is 100. That's another way that you could do it. So if I have the inscribed angle and I want to find the arc, I multiply by 2. If I have the arc and I'm trying to find the angle, I divide by 2. There you go. And don't worry, you're gonna get more practice with this on your homework today. Okay. Oh, yep, let's make sure we were correct. 24 and 100. Cool. Beautiful. Alright. Our learning target talked about needing to know what an inscribed angle is and what an inscribed polygon is. So, please put this in your notes, the picture as well. An inscribed polygon is a polygon in which all of the vertices lie on a circle. So you can see here that the corners are all on the outside of the circle. If you have something like this, that's not inscribed. That is not inscribed. Because this corner is not on the outside of the circle. So this is not inscribed. This is inscribed. All of the vertices lie on the circle. So this is inscribed. This is not. Okay. Is that in your notes? It should be in your notes. Okay, alright. Moving on. So, I wanted to review this. You don't have to write this down. We're just going to review this because we see the return of the word circumscribed, which we had lots of fun with in class, didn't we, 4th period? Okay, so an inscribed polygon is the shape inside of the circle. When a shape is inside of a circle like this, we call that circle a circumscribed circle, because that remember that means outside. A circle that is outside of the polygon. Okay, woohoo! Let's do some more theorems. So, this one, you are going to write down exactly how it is in the box. This one is a lot of words, and we gonna break it down. Okay, so let's read what it says first, and then we'll put it in words that we can understand. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. That's a lot of words. So, pause the video to think about how would you put that in your own words. If you had to put that in a way that you could understand it, how would you do it? Here is how I want to put it in words for us. I want you to put this picture in your notes, and we're going to say, if an inscribed angle intercepts a semicircle. Remember, a semicircle means that we have a diameter. Then the inscribed angle is 90 degrees. And this is magical. This is very magical. So no matter what, if you have a diameter, okay, this is getting muddy. If you have a diameter and you have a angle that intercepts that diameter, this will always be 90 degrees. Always. So in this case, angle B is 90 degrees. Because my inscribed angle intercepts a semicircle. And remember, semicircle means half a circle. Okay. So make sure that this is in your notes. The easy to understand version is in your notes. You could put this version in your notes if you wanted to. I think it's a lot of words. Make it easier for yourself. Okay, and then our next theorem, this one, the inscribed quadrilateral theorem, says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Ooh, okay. So if you see a quadrilateral, quad means four, a four-sided shape, if you see a quadrilateral perfectly with all of the vertices on a circle, that means that the opposite angles have to add up to 180 degrees. That's what supplementary means. Supplementary means that they add up to 180 degrees. So, you see a quadrilateral inside a circle. Opposite angles, supplementary. Opposite angles, supplementary. Okay, let's see examples of these. So, in case you're still confused about what those theorems mean, we're going to see an example. Okay, find the value of each variable. All right. So, let's look at A first. What I'm noticing is that AB is a diameter, which means that this is a semicircle. So, this is 180 degrees, which means this has to be 90. Because just like our first theorem says, if an inscribed angle intercepts a semicircle, the inscribed angle is 90 degrees. This angle right here, this inscribed angle, intercepts that semicircle. So, it's 90 degrees. Cool. So, 2x equals 90. Divide by 2. And we get that x is 45. Ta-da! Yes, sorry, Bob. So make sure that if you have a inscribed angle that intercepts a semicircle and you have a diameter here, boom, 90. Boom, 90. Just Yeah, make it easy for yourself. Okay, now, this next example, let's switch colors here. Now for B, we have a quadrilateral with all the corners on the outside of the circle. Now, what was that second theorem that we saw? If a quadrilateral can be inscribed in a circle, its opposite angles are supplementary. Opposite angles are supplementary. So that means that Z and 80 are supplementary. They equal 180. And Y and 120. They have to equal 180. Remember, this is what supplementary means, that they add up to 180. So, this means that Z has to be, I don't know, what is, subtract 80 from both sides. What's 180 minus 80? You know. This means Z is 100 degrees. And let's see, if something plus 120 is 180, that must mean that Y is 60. Opposite angle supplementary. That's it. That's it. Okay, alrighty. Let's check and make sure we were right. Ooh, 2x equals 90, x is 45, Z is 100, Y is 60. Boom. Boom. Okay, alrighty. Questions? At this point, if you have questions, actually, remember that the live streams are not a thing anymore. As of the week of April 20th, we are no longer doing live streams. Instead, we are doing Google Meets. Turn into our Google Meets. Tuesday through Friday. You've seen the schedule by now. There's another YouTube video about it. Go watch that one if you don't know what this means by now. But you should. You should be coming to our Google Meets because I want to see your face. I miss you. And I care about you. Okay. If you have questions, make sure to ask them. Make sure to ask them. This is what your homework looks like. 3 through 8 and 13 through 16. So just 10 questions. That's it. Awesome. This one is like example 1 and this one is like example 4. So this is like the first example we did. This is like the second example we did. Awesome, awesome. Okay. And the last thing I have for you today is your launch. This comes from Ella Fitzgerald, and it says, "It isn't where you came from. It's where you're going that counts." And I don't totally like how this is phrased because where you come from is very important. Where you came from is very important, and you should hold that dear to your heart, where you came from. What I do like about this launch is that it's focused on the future. Just because you came from, and maybe you don't like where you came from. Maybe you came from, I don't know, someplace that you didn't like, or maybe you came from somewhere that wasn't where you want to be. That's okay. You get to decide where you're going, and that's what matters. So if you don't like where you came from or where you're going, that's okay. Change it as you go forward. Change your life to be the way that you want it. But please don't think that I mean where you came from doesn't matter, because your roots are very important, and you should hold that very near and dear to you. But keep your eyes focused on the future, and make sure that you don't want to just coast through life because, Mom, well, I like where I came from, I'm fine. Like, no, keep working hard, look to the future, and look at where you're going, as well as treasuring those roots and the place that you came from. That's my launch for you. Take it with you as you go throughout your day. Have a wonderful rest of your day. Thanks for watching. Bye.